Hello everybody, welcome to a little tutorial on how to do WingCAD for the Design Build Fly team at the University of Florida. These are just the methods that we currently use to make our balsa monocoat constructed wings. In this tutorial, you'll learn how to import an airfoil into SolidWorks, how to make the overall solid body, then how to do the aileron cut, add the other lofted details, the spar holes, the stringer holes, and the front skin, then two methods of doing lightning holes, as well as the final rib slicing. This assumes that the viewer has an adequate understanding of how SolidWorks works. And yeah, without further ado, let's go. The first thing that we're going to need to do to start making our wing is we're going to need an airfoil. That's the outline of the wing that we're then going to lofted extrude into a bigger shape. Start by going on this website. It's airfoiltools.com, and you can use the airfoil search tool here to look for any airfoil that you want that's within their database. Today we're going to be using the Clark Y. This is kind of a classic airfoil. It's not necessarily the one that we're using on the plane. Well, it's not the one that we're using on the plane, but we will be using it in this case for demonstration purposes because it has very nice and not complicated geometry for SolidWorks. So, you're going to open up the page with your airfoil of choice and go to where it says Selig Format Dat File. Click on that and it'll bring you to this area with a bunch of numbers. Go and highlight everything from here on down to the bottom. Control C to copy that, then open up Excel. Hit Control V to paste all of your numbers into there. And you'll notice that it appears as though nothing has shown up. So, you're going to want to go and highlight column A, then go to the Data tab up above, click Text to Columns, and then you're going to click Delimited, Next, and under your delimiters, you're going to click Tab and Space. This, and then you're going to click Finish. This, essentially, you take all of your numbers from earlier, and then you paste them into Excel, right? And then Excel is just reading that as a bunch of different number values right next to each other, and you're telling Excel every time there's a space or a tab, split it into the next column over. So you're going to go here, right-click on column A, and just delete that. Next, go to cell C1, type in 0, and double-click the bottom right corner to populate that through down to the bottom. This Excel file is your list of coordinates that we will import into SolidWorks that will give us the outline of our airfoil. So, to put this into a format where we are able to import it, go to File, Save As, go to a location of your choice, and then you're going to save this, specifically change the file type to Text Tab Delimited, and then save it with a name that is meaningful. I'll save it as clarky.txt. And we're ready to move on. To import the actual airfoil into SolidWorks, we need to first make a new part. Then go to Insert, Curve, and curve through XYZ points. Make sure that at this point you've closed out of Excel or SolidWorks is going to get really upset with you. Click on Browse and go to the location where you have it. Change your file type to text files, and then click on your curve. Sometimes SolidWorks will tell you that there are self-intersecting points once you go to click OK. To fix that issue, scroll all the way down to the bottom, and then click on the point column, and then just hit delete on the bottommost point, and then hit OK again. And that should fix the issue. In this case, the Clark Y airfoil does not have any self-intersecting points, and we're good to just hit OK on its own. We've now inserted the curve as geometry in SolidWorks that we will later be able to reference. The way that we make a wing is essentially we CAD up half of the wing at a time, and we add all the details to it, and then we mirror it over a plane to produce the geometry for the other half of the wing. So we're going to start by clicking on the front plane, because that happens to be coplanar with the curve we just inserted, and let's make a new sketch. To turn this curve into usable geometry that we can base our wing off of, you're going to want to click on the curve in the tree, and then click on Convert Entities, and that will turn the lines black, meaning that you're allowed to, they're in your sketch now, and you can manipulate them. Next, we're going to need to make our chord line, so go over here and start a center line. Zoom all the way into the back. And in this case, actually, we are going to need to close the curve. So just click on these 2 points and just close them off. It's fine that this is a vertical line, because if you scroll back out, in the grand shape of the airfoil, this little discontinuity is not very significant, especially with the manufacturing methods that we use, that being a laser cutter cutting out the balsa ribs. That little amount of detail is not going to show up. Next, we need to make our chord line. So go up here and start a center line, and then you're going to start by connecting it to the farthest back point on the airfoil. In this case, since our 2 points here were directly on top of each other, there's not one that's farther back than the other. We're just going to start it at the midpoint. And then zoom out, and then go up to the front here. Go right under the leading edge area. Click to make it coincident with the airfoil, and then drag it off into the distance, being sure not to set any relations on accident. Now click Escape to stop creating new center lines. Click on this, your outer one, and then Control-click onto your airfoil curve. Make them tangent. Now essentially what we're going to do is we're going to click on this one, and we're going to mate it with the chord line. We're going to add a relation that will make them perpendicular. And what that's going to do is it's going to stretch this line out to its longest possible length from the trailing edge up to the leading edge, and that will give us our chord line. Next, what we need to do to be able to manipulate the length of this airfoil is we need to click on this on-edge relation and hit delete. It's going to get upset with you because it's based on geometry that's from a curve that you're deleting the relation to, but now you are able to manipulate this airfoil in the way that you want. So we're going to go to Smart Dimension, and we are going to set the chord length of our root rib. In this case, we're going to do 12 inches. Go ahead and click Exit. There are some parts that are underdefined here, and that's okay for demonstration purposes. If you want to go and redefine where everything is to set everything in stone, that's also good. But as long as you're not going and tampering with it, it'll be okay for now. So, we, in this example, are going to make a wing with a 5-foot wingspan, a 1-foot root chord, and a 9.6-inch tip chord. It is going to be tapered around the quarter chord point, and I'll show you what that means in just a second. And so since we are working with 1/2 of the wing at a time, we are going to need to make some reference geometry for that half of the wing. So go here, click on your front plane, then go to Features, Reference Geometry, and make a new plane. We're going to extend it outwards in this direction, the equivalent of 2.5 feet, since that's half of our wingspan. So 30 inches, outwards, done. This plane 4 is where we will be creating our next sketch. So when I said earlier that the wing is going to taper about the quarter chord, it means that if you're facing the wing directly onwards from this angle, the quarter chord position along the root chord and the quarter chord position along the tip chord are going to be at the same location. So to do this, first we're going to go over here and hide this first sketch just so it doesn't confuse us. We're also going to hide the front plane, and we're going to make a sketch on plane 4. Similarly, we are going to take our curve 2, convert entities, and we will repeat the same steps as before. Okay, so next we're going to take this chord line and we're going to make it horizontal to make sure it doesn't rotate during our next set of manipulations. And we're going to smart dimension this chord line to be 9.6 inches because that is our desired tip chord length. So we're going to hit check here, and then we're going to take this whole thing and we're going to move it off to the side. Click on the origin and click on the chord line. Make them coincident. That way they will be at the same elevation the entire time. Click check, and then we're going to put a dimension from the tip to the origin. This is going to be our offset that's required to get us to line up our quarter chords. The dimensions for each offset will change depending on the specific geometry of your wing, but in this case we're going to go for 0.6 inches, and that should line our quarter chords up. So next hit check, exit, and we are ready to do our first lofted extrude. So to do our extrude, I'm going to make sketch 1 visible again. I'll go ahead and hide plane 4, and I'll hide the curve just to make sure that it doesn't get in the way. Next, we're going to go to a lofted boss/base. We're going to open up our tree, and for our profiles, we'll click on sketch 1 and sketch 2. You might have to drag these dots around depending on where exactly they end up, and just check to make sure, especially if they're at the back edge here, that they line up at the same place and don't create any weird geometry. In this case, we are good to do the loft. So, click check here, and that's the overall shape of our wing. Since we don't need to see these sketches from before, I'm going to go here, and I'm going to hide sketch 1, and next we can work on the aileron cut. To do the aileron cut is very simple, so we're just going to click on the top plane, we're going to make a sketch on it. So this is our root and this is our tip. In this case, our aileron is going to extend from the tip up until 1 inch before the root, and it's going to be 30% of the mean aerodynamic chord, which in this case is going to be a cut in of 3.24 inches. What that means is we're just going to take our lines here, we're going to go to this edge, click on a point there, go up to here, click on some arbitrary point there, go back in, click here just before the root, and then make a line out to here, making sure that it's coincident with this edge, and then bring it back to your first point. This shape is just going to be extruded cut through all on both sides, and the remaining shape of the wing is what we will base our ribs off of. So to dimension this, we're going to set this to our desired cut-in distance, in this case 3.24, and on this side it happens to be the same measurement, but sometimes it can be different measurements. And then we're going to go here, set the distance from the root to the beginning of the cut-in to 1 inch. Exit out of the sketch, and then do an extruded cut through all on both sides. Click check, and it should look something like this. This is the overall shape of the wing minus the control surface, in this case the aileron. This next part of the video is going to be where the lofted cut becomes your best friend. But first, we're going to make a regular extruded cut. In this case, the cut is going to be for our spar hole. We're going to use a circular spar. They're not necessarily structurally ideal, however, they are affordable, they're easy to manufacture, and they fit perfectly well in this case. So here we're going to do a circular spar of, let's try 0.75 inches in diameter. And we're going to try and locate this at a position which is roughly along the quarter chord. So once we have that dimensioned up, we can exit out of the sketch and we can do an extruded cut through all. And that will carve out our spar hole through the ribs. So in this case, once we add all the extra details and we slice up the ribs, that would be where a carbon fiber tube could go through to support the wing against bending moments. Next, we're going to add the stringer holes. Now the stringers are our version of a stiffener for the wing skin. We use 1/8 inch square prism balsa wood, really long pieces, that we cut little slots into the rib, and then we fit them in and we glue them down. And you'll see what I mean in just a second. So, for our first sketch, let's click on this face of our tip rib, and let's begin. So we're going to want to make a little cutout for our stringer to rest in. And we're going to very carefully not add any relations on accident here. And we're going to draw out 3 sides of a box. We're going to connect these, make them equal, and then we're going to make them all perpendicular to one another. This will give us 3 sides of a square. And you might be asking, well, why not just make the entire square in one go? And that's because if you were to make the entire square in one go, and then loft it, extrude it to the next side, it will likely leave a little lip of material on top. And that lip of material is undesirable because it's not reflective of reality. It makes things complicated for the model. It looks ugly, and we want to get rid of it, right? So we take a tangent arc, and we just go from this end here directly onto this end here. Then we're going to smart dimension this. That way each side is 0.125 inches. And we can locate this about a certain point here if we desire. In this case, let's say 2 inches. And I'm going to repeat this in multiple locations on each side. Now all of our stringers are done. In this case, I've chosen to do 6. The number you choose can depend on the geometry, especially the curvature of your airfoil. And essentially what you want to do is you want the spaces between each stringer to be as roughly flat as you can make them. Now, sometimes you have a little bit of curvature, and that's okay, but you want to try to minimize the curviness from one point to another. Also, try to space them roughly equally with one another. Try not to have huge gaps and then really tiny ones right next to each other. The goal of a stringer here is to essentially take the heat shrinking plastic wing skin that we put on and separate it into smaller segments. That way they don't buckle as easily when the wing is bending. We're going to repeat this on the other side, and then I'll check back in. So, with all of our stringer hole sketches finished, we are now able to begin making our lofted cuts. I have made each of these sketch profiles into its own unique sketch as opposed to doing them all in one. That way we can easily hide, show, or manipulate one single stringer slot without worrying about affecting the others. So, let's go to lofted cut. We're going to need to pick our matching profiles. As you can see, I've done an equal number of profiles on each side of the wing, and I've tried to roughly keep them at similar positions relative to one another. So, in the first case, we'll click on this sketch, and we'll click on this sketch, and we'll loft them into one another. We have to play around with this green dot to make sure that it's in the same place on each sketch. But once it lines up, it'll form a stringer hole that we can then cut. And we have a straight slot that we can fit our 1/8 inch stringer into. Repeat this for the other 5 lofted cuts. Once this is done, your wing should look something like this. Next, we're going to make the front skin to handle the curvature at the beginning of the wing. So when we create our wings, we essentially have a series of ribs, a carbon fiber spar in the middle, stringers, which keep the skin adhering to the curvature of the airfoils, but then we have this front area, which is really curved. And if we try to put the heat shrinking plastic on just that, it would want to suck into the gaps between each rib. And so to avoid that, we have a really thin sheet of balsa wood that we glue to all of the ribs. And that forms a nice smooth curve that we can layer the monocoat over. And it's rigid enough that it won't bow in when we heat shrink it. And to do that, we're going to need to make another lofted cut. So, let's do a sketch onto our tip face and this one can get a little tricky. What we're going to want to do is we're going to want to convert entities and only click on this first part of the edge. There's a reason we did the stringer holes first. It's because it separates this into a nice little segment that we can manipulate later. So we're going to convert that, and then we're going to click on this. We're going to offset it in both directions by 1/16 of an inch. Then we're going to hit check. For this next portion, SolidWorks can get a little tricky to work with. We're essentially going to make little lines here from the top segment to the bottom segment. And then in this case, SolidWorks just decides to throw it at the bottom there. So we're going to take it and we're going to drag it along the curve a little. We're going to click on this line and we're going to click on the outer segment, and we will make them perpendicular. And then we're just going to click on this endpoint, and we're just going to walk it around the curve here until it's at a location that we agree with. Then we're going to click our dimension. We're going to make it so that this is a set distance away from here. In this case, we will do 0.2 inches. And then we'll repeat the same thing on the bottom. So next, we're going to click on this middle line here and click For Construction. Click check there, and then we're going to trim a couple entities off the edge. Now we're left with the profile we actually care about, which is the segment of the front skin that we are going to carve out of the rib. This provides us a little slot that we can lay up our thin sheet of balsa wood on top of. We'll make a similar sketch on the other side, and then we will do a lofted cut to finish it off. Again, you might need to play around with SolidWorks a little bit to get the geometry to cooperate with you, but this is our end goal. We can go here, and now we can do a lofted cut. From our first profile over to our second profile, we make sure that the green dot is in the right place, and then this is what it should look like. Click check, and essentially you have carved out a little bit of the front area. This is where we would put our thin piece of balsa wood over. This next part can be done in two ways. These are lightning holes. Essentially, when your wing, or when your airplane is flying, most of the load is going to be about the quarter cord, and it's going to be transferred through the spar into the rest of the plane. And areas like this over here and this over here aren't necessarily doing a ton of the work. So there's not necessarily a point having all of this material there. So what we're going to do is we're going to make a sketch onto here, and we are going to essentially drill holes through these ribs. And there's two ways to go about doing this. The first one is that you can just have a circle. This is easy, it's safe to do. Just put a circle there, and then in another sketch you put a circle there, loft it through the different segments, and that works perfectly fine. You remove all of this mass, and then you save a ton of weight. Now what else you can do is what we're going to show you now, which is you kind of just trace out almost the outline of the airfoil, and you have a more optimized method of weight reduction because you're encompassing more area with the holes that you're drilling out. And you're going to want to give these, if you're tracing it out like so, you're going to want to give it decently sized fillets. That way you're not creating crazy stress concentrators. So just do a profile like so. Click check. Once we've made this sketch, we're going to want to do a corresponding sketch on the other side. So we're going to click here, make another sketch, and we are going to similarly sort of trace out the path of the airfoil. I like to have these side faces be vertical and then kind of match the flow of the airfoil on top. Once again, put your big fillets in. And this is the part where you kind of go a little loosely with it. A lot of it is, there are mathematical ways to optimize it, but at our scale, it's okay to just sort of freehand as we're doing right now. We're going to make a lofted cut from our first profile into our second. We're going to make sure that the green dot is in the same space. That way we don't have any conflicting geometry. And we're going to cut through. And we're just going to take a peek down to make sure that we are not intersecting any of our stringer holes, because that would be very bad. That would lead to the ribs essentially splitting when they're being cut on the laser cutter, which is not good. So we've done that on this side, and it looks pretty good. We will do that for our other back section here, and then our front area here, as well as this area on this side. So once you have all of your optimization holes filled out, you are now ready to slice up the ribs. We're going to do this by making a sketch onto the top plane. And this sketch is going to be one big extruded cut through all, which will divide up this into little slices, which are going to be our ribs. We'll start by locating any fixed geometry, and essentially each slice is just going to be a big rectangle. And we're going to dimension these rectangles relative to where we want our ribs to be. So each rib is 1/8 of an inch thick, because that's the size of the wood that we have in the shop. And so if we dimension it as so, we are able to, essentially when we cut through this sketch, we'll be left with a segment here, and then a segment here, and then another one, and onwards, the more rectangles we include. So I'm going to add more rectangles. Let's say for this wing we want 10 ribs. So I'll go add more rectangles. And then next, we're going to move on to the tip. We'll take this line, and we'll dimension it to here. We will make it equal to 1/8 of an inch. We'll go to any constraining geometry, which in this case would be here. We do want this to be one defined rib. So we'll take this here and make it collinear with that edge there. That way when we go to extrude them, it'll be one flat rib here, one flat rib here, and then onwards to the others. And then we're going to dimension the gaps between each of these rectangles at 1/8 of an inch. Now ideally, we would then take each of these little ribs here, and we would make them all the same length, right? We would set them to be equal to one another, and that would give us a much more equal distribution of the load being taken on by each segment. But what ends up happening is if we go to evaluate and measure this, in this case it works out perfectly fine because it's just 3.5 inches, but in a lot of cases it'll be a number with a huge decimal portion afterwards, like to the point that it would be very difficult to manufacture to that standard. And so what we would do is we would set each of these ribs, except for the outermost one, as being equal to one another. And then you would manipulate that equal dimension, and this outer one would change to just fill the little gap out there. And you would set them to something that you're able to dial in with, say, like a pair of calipers. And you want them to be roughly equal, but it's okay if the outer one is like slightly not. And so we have our big sketch here. We can then just exit out of the sketch, go to our features, do an extruded cut through all on both sides. When it says bodies to keep, click all bodies. And here are our ribs. The last couple of things that need to be done to change this from just a set of things that we can reference to cut on the laser cutter into an actual usable CAD model in an assembly is first we're going to go and edit the material. We're going to set it to balsa wood because that is the one that we use. And then we're going to go ahead, take our front plane, and then we are going to do a mirror. We're going to go to Bodies to Mirror, drop down our tree, click on Solid Bodies, and then click on all of these. And then we're just going to mirror them over to the other side. In this specific model, we happen to have a rib right after the front plane, and this of course is not how it would look like on an actual airplane, and so what you would do instead is you would set another reference plane a certain distance off, and that distance will allow that reference plane to be at the center line of your wing, and then you'll mirror one side of the wing over that, and that'll allow you to get your final geometry. The exact location of mirrored parts within your CAD model is going to depend on whether or not you have a high wing, or a mid wing, or low wing. There's plenty of different details that can be changed around with the wing CAD. It's just up to you to figure those details out. Thank you all for watching, and I will see you next time.